I'm going to ask you to tell me, on these two things, what's same and what's different. So first I want you to tell me, what's different? What's different?
Color.
Color is different. Good boy, you're right. Okay.
Alex the parrot is one of a long line of students trying to help scientists understand the animal mind. He's been talking for 18 years, and he seems pretty clever. But does he know what he's saying?
Yeah, that was good. Color is different. Now I want you to tell me, when you finish that nut, I want you to tell me what's same.
Shape.
Shape is right. Good boy.
Science faces huge problems when it tries to explain what Alex's skills might mean.
Yeah, good boy.
Cork.
Oh, you want cork. I thought you'd want a cork. I thought you'd want a cork. No?
Go back.
You want to go back to Kelly? Okay, you can take a little
Alex
break.
speaks like a human, but does he think like one? What is it like to be a non-human animal?
Tickle. Tickle.
Let me give you an example of why it might be important. There's a great debate, of course, about animal welfare. Do chickens suffer when you keep them in battery cages? Do sheep suffer when you're transporting them in lorries? Now, a lot of the argument there is based on an anthropomorphic view of the behavior of animals. People say to themselves, well, I wouldn't like to be cooped up in a lorry at 95 degrees Fahrenheit for 6 hours being transported over to France. But if you really want to ask the question, does the sheep mind or does the chicken mind, we've got to understand how animals perceive the world, what level of self-awareness, what level of consciousness they have.
Consciousness, self-awareness, insight into one's own thoughts and feelings. It's the most elusive and intriguing problem in science. Do non-humans have it? Or are they more like soft automata, unconscious robots? Early scientific dreams of reducing all behavior to stimulus and response now seem naively optimistic. And in any case, animal thoughts and feelings were simply left out. Equinox visited 10 specialists in zoology, psychology and philosophy to hear about the extreme difficulty of penetrating the darkness of the animal mind. It seems that clues are to be found in unlikely places by scientists asking unusual questions.
I was curious to know whether vampire bats were capable of regurgitating blood or sharing food with individuals that might not be related to them. The work spanned a 5-year period, and we spent over 500 hours taking notes on what the bats were doing. Trees were very big. You could lie down inside the trees, and so they were home to lots of other animals, giant cockroaches, snakes, porcupines. Occasionally a basilisk lizard would come into the trees. Vampire bat roosts are easy to find because they only eat blood. Blood is primarily protein, so when the bats defecate, it has a very strong ammonia smell. So you can smell a vampire roost at several yards before you enter the tree. We had to wear respirators, masks, to protect ourselves against fungus that grows in bat guano in some of these sites. And that actually helped, prevented the smell from being overwhelming. But they're fascinating animals. It actually was quite fun. The bats have heat sensors in their nose to locate places on the animal's skin where the blood vessels are close to the surface. So when they make a bite, by using their incisors, which are sort of like taking a golf swing, taking a divot out of the earth, they take a divot of flesh out of the animal's skin, and the anticoagulant in their saliva causes the blood to flow continuously. They lick the blood just like a cat licks milk from a bowl. But finding a cooperative animal is clearly not that easy. By netting animals returning to their roost sites, we were able to discover that young animals less than 2 years of age don't feed successfully about 20% of the time. They come back after spending the night looking for food, and they come back essentially empty. And those are the bats which beg from other individuals in the group and are almost always fed. One bat gave away blood. Subsequently, when it was starved, it was more often than not fed by the bat that it had fed. And they reciprocated these sharing events. That, to me, is the really unique part of this story.
So it does seem that vampire bats have friends and know how to recognize their friends.
If by friends you mean you're willing to give away something which is food in your stomach. I mean, that certainly seems to be true.
Wilkinson's study is scientifically important because it showed that altruistic food sharing occurs in unrelated mammals. In the search for animal awareness, it's suggestive. But does it tell us if the bats are aware of what they're doing?
Designing an experiment to have an animal tell you what it's thinking is difficult because you can't talk to the animal. And you run the risk of introducing your own perceptions into what that animal is doing. What can they do? We really haven't really scratched the surface for most species.
It's very difficult to imagine whether an animal knows that it's alive and where it is. I'd like to know if they know that themselves. I'd like to know if my dog knows their dogs. I think that's the thing that I would like to know best. Well, you see by looking at me that I'm a pet lover, and I think all pet lovers up to a point have a bit of an anthropomorphic view about animals and sort of associate them with themselves. But I have really, I'm trained also as a scientist, and I have no views. I have absolutely positive that animals do have emotions and that I can relate with animals and that they're not robots. Consciousness is something quite different. I think you could have emotions without being conscious. And I think that with human beings, too, there's different levels of consciousness. And I think that quite a lot of the time you're not conscious at all. And it's been revealed, hasn't it, by Freud, that there's a great deal that happens to you, that influence you, that is important to you, which you're totally subconscious. You don't know anything about it. And I'm sure that it will be the same with dogs.
Experiments in the United States have shown that few animals learn to recognize themselves in a mirror, but the chimpanzees and orangutans do seem to understand their own reflections. Surely this is strong evidence that great apes, at least, know who they are and share our kind of self-awareness.
It's interesting that chimpanzees can find out about the state of their body by looking in a mirror. But does that really imply that the chimpanzees know something about themselves in the way in which we normally think about the human self? It doesn't, as far as I can see, imply, for example, that the chimpanzees know about their own mortality, know that they began at a certain time and inevitably they will die. That's an important part, I think, of a human self-concept, to recognize that we're mortal. But the capacity to use a mirror implies you know something about your body, but not that you know something about mortality. The problem is that as most of us understand self-awareness, we only have one case to go on, our own. We know for sure, I know for sure, that I am conscious. Now, when you have that sort of view of what consciousness is, as something intrinsically private, then really it's the case that you can't know for sure whether any other creature is conscious. So the possibility arises that they're not, that they are all little robots, behaving cleverly, but there is no internal light on, as it were. If a creature is not conscious, as we normally understand consciousness, as a private thing, then it's something like a sleepwalker, or as we conventionally understand an automaton or a robot to be. And it's conceivable, it seems to me, that animals are like that. That doesn't mean we should assume that they are.
If you look at the song of a nightingale, it's enormously complex. In fact, I totted it up and it has more notes in it than Mendelssohn's Violin Concerto. A nightingale only has to hear the tutor song once and it can reproduce it, note perfect. Well, one good example of remembering things is animals that have the habit of storing food, like squirrels or certain members of the crow family or titmice. Imagine you hid 10,000 bunches of keys in your house in October and you wanted to go back and find them the following May or June. How good would you be at doing that? Would you be able to find all of them? Well, some of these birds, and probably squirrels as well, have a memory that allows them to solve that kind of task. You shouldn't assume that just because an animal has a good memory that it's aware of what it's doing or that it has any form of consciousness. After all, your laptop computer can store huge amounts of information, but most of us wouldn't tend to think that our laptop computer is aware of what it's doing. It could be behaving just like a robot, that when it's at a certain level of hunger and there's a certain amount of food around in the environment, the machinery of the brain triggers off food storing behavior. It would really require some very sophisticated experiments, in fact experiments that have not yet been devised, to find out if the animal is aware of the future consequences of what it's doing now. For me, the essence of consciousness is creating a virtual world in the mind to be able to anticipate or rehearse things that might happen in the future. And I see that as being rather a different aspect of behavior from remembering what's happened in the past.
Science doesn't insist that animals are unconscious robots, only that there's no good evidence that they're not. Ravens are clever birds, but a prominent American zoologist was sticking out his scientific neck a long way when he claimed that ravens can look into the future to see the solution to a problem they've never encountered before.
Well, the problem I gave them was to get food that was attached on their perch, dangling on a string. How do you get that food?
The experimental birds were hand-reared in an aviary and had never seen meat on the end of a string before. Heinrich is a world authority on ravens, and he's sure that nothing they do in the wild is remotely similar to this.
The way I saw it was, maybe it's a rare phenomenon. However, it's like genius. It exists, and if you show that it exists, that's all that's the important point. Anyways, I wrote it up and sent it in to a scientific journal, and it wasn't accepted. All I can say is that the comments that I got sounded like people were threatened, because they seemed to go out of their way to say nasty things that really didn't pertain to the paper even. And I just couldn't understand that. Well, right now they're a little bit, well actually they're probably quite a bit afraid of you, because they're only used to me, and any stranger they treat like a strange animal. I mean, they recognize individuals, and now they're hiding up there in their roost, where it's dark and they're protected, and that's their safe place, and that's where they always go. And that's where they'll stay as long as they see or hear you anywhere near here.
The original experiments were filmed by Heinrich in 1992, but he tried it again for us at his home in Vermont.
Okay, that's Goliath. He just got the meat. This is on the 17th of September, and this is the first time that they've ever done it.
Heinrich's critics were annoyed by his refusal to accept instinct or trial and error learning as an adequate explanation, and by his willingness to credit the ravens with insight in solving the problem.
By insight, I mean having a mental concept of a problem. In other words, here's a problem, and having a mental concept of a solution, and then doing the steps in the mind without doing it with the body first. In other words, I'm not saying they haven't done all the steps. They might have tried them all out, but they tried them out in the mind. They said they visualized that to pull on this string makes it come up, and to put it here and to put this on top means to hold it. In other words, they have visualized the consequences before actually doing them physically. That's what I would call insight.
Well, his interpretation is that the raven has what you might call the aha experience. It looks at the problem, works out a solution, and then goes straight to the final act. The alternative interpretation, what I would call the killjoy interpretation, is that what has been observed in a very much speeded up way is a sequence of trial and error learning. If you filmed it and slowed down the film and looked at it frame by frame, what you might see is the raven actually picking at the string, noting that the meat gets a little bit nearer when it tugs on the string, dropping the string, repeating that act, and gradually learning over a very rapid time period, maybe only a few seconds, to get the meat by pulling on the string. So there is a killjoy explanation that doesn't involve this leap of insight.
Animals can perform some very complex behaviors without being consciously aware. That's conceivable because we know that we humans can do some pretty complicated things without being aware of ourselves doing them. For example, assembling the words in a sentence. It's a really, when you try to get a machine to do it, when you try to get a computer to do it, to line up those words ready to go out in a comprehensible sentence, it's a very difficult thing to program a computer to do. We're doing it all the time, and we don't know how we do it. We don't have conscious access to that complicated sequencing process. So we know that complicated mental things can be done without conscious awareness.